All right, so we're going to get started drawing with P5. So the first thing that I want to do is I want to, as linked in the class notepad, I want to make sure that everyone has the reference page open for P5. So I'll give you a moment to get that going. There's a link in the class notepad, and I'll just pop a link into the chat. Oops. The chat as well. So as discussed, P5 is going to work with, it's a JavaScript library that works with HTML to make visual drawings in what's called the HTML5 canvas. The first thing that we want to remember is that our code runs in order, right? If we look here, we have these numbers. Those are the lines, the line numbers of the code that we've written. So it runs lines 1, 2, 3, 4, 5, 6, 7. And then after it gets to the bottom, depending on how you've structured your code, certain sections may loop. There's other instances where stuff will loop before it makes its way to all the way down to the end of the code. We're not there yet, so don't worry about that quite yet. But I'll just add in the comments just as we go. Remember, setup function, this setup runs one time at the beginning, and the draw function runs over and over. And so before we go any farther, let's make sure to save. So Command S for me, and I'm going to rename this. This is going to be MMP 210. Spring 21. 210 is the 10th, yeah. All right. So there's we've renamed our code something that we can find again. Because once we come back and want to work further on our code, if we go to File, Open, and we have a whole bunch of things that are named like Exquisite Panda and Melodious Cat, or whatever, all of these random names that P5 generates, it's going to be a mess in here. So if you're able to name things in ways that you remember, it's going to save you so much grief later on. All right, so excuse me. First things first, let's just run our code so we can see what happens in our preview here. So I'll press play, and all we have, as expected, is a 400 pixel wide by 400 pixel tall area that is gray. So that 400 pixel by 400 pixel, that is the size of the HTML canvas that we're using. And we've used the background function, and that creates a color that takes up the entire canvas. So remember, comment, comment, comment. All right. So now that we have a background color, we might want to change that. I don't know, that depends on what it is that we're making. Maybe I want to make something that is, I'm gonna make something in the desert. Yeah, that sounds good. So we're gonna, I'll make a comment at the top. This is example desert. Desert has one S, yes. Desert has 2 S's. Example desert drawing. And so I'll save that. Remember, just always be saving, save, save, save. And so for the desert, I'm going to start out with a blue, nice blue sky that takes up most of the frame. So for blue, remember our background function can, well, maybe I don't remember. Let's just check in the reference section. So I go to my reference section. I can use this search, or I can use find in page, one of the most important things to remember for quick internet searching. If you're not already doing it, Command F or Control F on Windows, and I'm just going to type background. Oop, there it is. Great. Click it, and now I can see the parameters that this function requires. So remember, there's the name of the function, then parentheses, and then inside of that parenthesis is our parameter or multiple parameters potentially. So if we have one parameter, this is reiterating from last class, about one parameter, we're going to get a grayscale image, something between white and black. If we specify 3, then we're going to get, we're going to be specifying our red, green, and blue color channels. And there's other options as well. We can use named colors, like the colors that you can reference in like HTML and CSS. You can use hexadecimals, both 3, well, not really digit, but you can use 3-digit or 6-digit hexadecimals. You can use nested functions, but let's not get ahead of ourselves. HSB is cool. We're not going to play with that yet, but it's a different way of defining color that's a little bit more intuitive. Possibly it goes through the rainbow as a set of, instead of being red, green, blue. But we're going to stick with red, green, blue just for now because it's the default. So red, green, blue color standard or color channels. So we'll go back to the editor. And so if I want a blue sky, but I want like a nice light blue sky, then that means I'm going to have probably full blue, and I'm going to have probably equal parts red and green, not equal to blue, but they'll be lower. So I'm going to guess 100 and 100. So that it's kind of somewhere between white and blue. And let's just see what that looks like. Not quite. Let's try to add some more green, maybe. So this is, unless you have the RGB color space memorized, that's looking closer. There's going to be a little bit of guess and check going on here. So I'm going to just keep eking up on what I think will be a nice pale blue sky for a desert. I'm going to try to go a little bit more green, maybe. We're getting there. Just try 200 here. Oh, not 2000, that's too big. And remember to keep in mind that the maximum amount you can have for these color values is 255. There, that looks perfect to me. That looks like a nice pale desert sky. So the next thing I might want for my scene is a yellow, beige, brown ground. So if I want to make something that takes up the bottom part of this canvas, what shape is that going to be? It's probably going to be a rectangle since we're working in a rectangular space. So if I want to make a rectangle, let's go back to our reference section. And I'm going to Command F, rect, and that'll get me there. And we'll just see if there's any others. We'll just go through. Nope, this is what I want. Rect is our rectangle. So the rect function, if we look, has, we can see it's using 4 parameters here. But wait, what is this? This one has a bunch of different parameters. These further parameters are for rounding the corners. It'll specify the radius that we're going to round the corner at. We're not going to round our corners, so we don't need to worry about that. But remember, if we keep scrolling down in this window, under the syntax header, we're going to find a bit that shows us what the parameters are. And so we have these ones here. We have the ones that are not in square brackets. Those ones are mandatory. That means that the rect function requires at least these 3 parameters. What they are yet, we'll look at in a moment. And then everything in square brackets, those are optional. Those will further specify how you want this function to be displayed, but they're not mandatory for the function to work. If you only specify 2 parameters, right, like if you just stop after X and Y, the program will say, what is this? You've made a mistake. I can't do this. We'll look at that going wrong in a second, but let's just go down here. So there's another way that we can use it that has a minimum of 4 parameters, where we'll be specifying some more details, which we can see here. So now, just moving down to this parameters section, we have the name of the, or the, yeah, we'll just call it the name of the parameter along with a description of the parameter. So number, that means that we can't pass a string into it. We talked about data types previously. When it says number, that means it's going to look for some sort of number data type. There's multiple kinds of number. We talked about integers, and those are numbers that do not have a decimal. Like so 1.1 is not an integer, 2 is an integer, 592 integer, 13 integer, negative 90 integer. No decimal points, no nothing after that decimal point, we have an integer. If there is a decimal point with numbers following it, then that's what's called a floating point number. The point is the decimal point that's floating somewhere in this number. And there's other types as well. There's ones that don't have negatives, ones that are have more options of like how much data is used to store those numbers. But for now, let's just worry about integers and floats. Floats meaning floating point numbers. Those are both number types of data, so we could pass either one of those in to these parameters. And these are continuing numbers. These are the radii that the corners might be rounded at. But once again, we're not doing that. We're just worried about these first 4, because all I want to do for my example, I want to make a rectangle at the bottom. This is hard to do without it being a mirror image. At the bottom of the screen, I want to have a beige sand colored rectangle at the bottom of the screen. So I have the x coordinate and y coordinate. We'll get to that in just a second. And then the width and the height of the rectangle. So that's pretty straightforward, x, y, w, h. So let's just go over here, and I'm just gonna type some stuff out. I'm gonna say first, make a comment, rect x, y, w, h, just so I can remember what all of those parameters are looking for. Okay, now we have to take a quick side trip to talk about coordinates. But first I'll save. Come on. What's going on? There we go. Strange. Okay, like I said, we have a quick sidebar to talk about coordinates. So let me go over to this camera. So for our coordinates, from math classes, you might be more used to a coordinate system that looks like this, where we have our y-axis and our x-axis. And then over on this side, we have our negative x numbers and we have our negative y numbers here, right? So if we looked at a coordinate here, like I'll just do 1, 2. All right, so if I put a point here, the coordinate for this is going to be 1, 2. So our x coordinate will be 2, and our y coordinate will be 1, 2, 3. Right. And for over here, we'll have 1, I'll just do here. That is 1, what? Sorry, my brain just 1, negative 2. This one here will be negative 1, negative 1. And this here will be negative 1, 2. Right? This is the coordinate system we're used to, where 0, our origin, is in the center of the world that we're looking at. This is not how we do it by default in P5. By default in P5, we have our canvas, and our origin is at the top left. All right, our origin is up at the top left. And we have positive X numbers are going to the right. So that part's regular, but positive X numbers, positive Y numbers are going down. So if we are specifying a coordinate inside of the coordinate system that we're using, inside of this coordinate plane, everything that's inside of our visible canvas, everything that is over here, I'm moving my mouse around now, everything that's inside of this viewable area is a positive set of coordinates. Both X and Y are going to be positive. There is the option to do negative coordinates, but that's all happening off screen. We could have a rectangle that has a negative coordinate, but we could be drawing it where we can't see it. That sounds useless, but it will be useful later. So just remember that even though we can't see it in our canvas, this space outside of our positive coordinates exists. And so continuing before we keep going with the actual coding of it, our rectangle function by default works the same way. If we draw a rectangle, the X and Y coordinate is defined by the top left. The XY is the top left. We have the width and we have the height. Those ones are still as we normally understand them. But the XY coordinate of our rectangle is defined as the top left. Just remember top left, top left, top left for a lot of things that we're doing. Okay, so with that out of the way, now we can continue on our merry way. Oops, come on. What is going on here? My mouse is acting a little weird today. But anyway, our rectangle is going to be, we're going to try to figure out what our coordinates and width and height of our rectangle are going to be. But first, if I draw a rectangle, let's just see what it looks like. Let's just put in some random, or not random, arbitrary. I want to remind everyone that there is a difference between random and arbitrary. Random is unpredictable, arbitrary is without reason. Okay, so if I just say 100, 200, 50 or 40, 70, let's just see what that looks like. Just put in some arbitrary values and run it and see what we see. So there we go. So the default fill and stroke, default fill is white and default stroke is black. So for us, we probably don't want that for like the ground that we're making here. So let's change those. So let's go back to our reference and see what our functions and parameters are. Fill is what we want, and that is inside of the color section here. And I would advise everyone, so in the class notepad, I linked to this specifically. Just go through these and check them out. Read through the descriptions, try them out in the editor. If it doesn't work, that's fine. Ask me a question. It's all good. All right, so fill, if I click here, now that is going to show me that fill works very similarly to background, to the background function, where it's going to just ask me to specify a color, and that will be the fill for everything that we draw after that, everything that comes later in the code, including in subsequent loops of the draw function. So let's just try specifying our fill. So fill, and I want something that's kind of a brownish yellow for like the sandy dirt. So that means I'm gonna have a lot of red, I'm gonna have a lot of green. I'll just start like that. And I'm gonna say I want a little bit of blue to like mute it out a little bit. And I'm probably gonna wanna have less yellow. I'm gonna guess, I'm gonna 255, 235, 80. Let's see what this does. I'm not sure. This is just guessing. Oh, not bad. I want more, relatively more red. So I'm gonna drop that down to 205. That looks pretty good to me. I'm gonna see if I can mute it up a little bit. So we'll go to 100 blue. Yeah, I think that let's just keep it. Try 130. Yeah, that looks better. That looks good to me. Maybe a little less. Yeah. Okay, so we have that. That looks like a pretty good color to me. But I want to show you something really quick, which is, so right now this fill is on line 14 and our rectangle is being drawn on line 15. So when we just follow through what the computer is doing with our code, it runs through the setup, okay, make the canvas, okay, draw the background, okay, change the fill, okay, draw the rectangle, and then draw the background, draw the fill, draw the rectangle, background, fill, rectangle, background, fill, rectangle, blah, 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 draw a loop over and over and over, right? So we're seeing this refreshing about 60 times a second at the frame rate of our monitor, that's about. If I move this here after the rectangle and I run this code, it pretty much looks the same. But if you're following along and you click it, you can see there's a little moment where it flashes white. So what happens here is when we run through the code as the computer would, okay, create the canvas. All right, make a background, make everything blue. Okay, draw a white rectangle with a black stroke. All right, oh, change the fill. Okay, draw a background that's blue. Oh, now draw a yellow rectangle because the fill function is persistent. It's gonna, whenever we specify it, it's gonna stay that way until we specify something else. So just keep that in mind. Remember, the changing fill is persistent. That. Okay. So now that we have our yellow color chosen, the next thing I want to do is I want to get rid of this black stroke. And I'll just go here. There's a function called no stroke right here. And it doesn't require any parameters. So we'll just say, right here, we'll say no stroke. So now we should have a rectangle without an outline. So that's looking pretty good. And pardon me. Now we need to move that rectangle down. So if we look at our canvas size, remember this is a 400 pixels from top to bottom. So I'm gonna just say that I want my rectangle to be about at this point. So I'm gonna just say that that looks like it's about 50 pixels from the bottom. Like if we have 400 divided by 2, 200, 100, 50, just dividing it in half repeatedly. I'm gonna say that I probably want my rectangle to be 50 pixels tall. And I want it 50 pixels from the bottom. So switching cameras. If we have our origin on the top left, then that means the y coordinate of the bottom here is equal to whatever our height is. So in our case, that's 400. If I want to start my rectangle 50 up, then that means at this point, the y coordinate is 350. And the height is 50, and my width will be the width of my canvas, which is 400. So going back to here, I can just populate those numbers into my parameters. So I'm going to say 350. Oh, sorry, that's my x coordinate. I want 0 because 0 is at the left side of the screen. 0, 350, 400 for our width, and our height is 50. And let's see what I did. There it is. We got our desert ground here. All right, so save. All right, and so now let's put put a sun in there maybe. So now I want to make a bright yellow fill. And also I'm going to make a comment here. Draw desert floor, ground. Now I'm going to draw a yellow sun. So I'm going to change my fill again, and we know how this works, red, green, blue. And so for yellow, a bright yellow, I'm going to choose all of my red, all of my green, and let's just try a little bit of blue in there to brighten it up. And for a sun, suns are usually round. So let's go look back at our reference section. Remember, the reference section is your friend. And a circle can search for, and there it is, there is a circle function. And reading the description is good here because if we think about a circle, right, a circle is an ellipse that is equal in aspect ratio. It's not wider than it is tall. It's not taller than it is wide. So we can use the circle function, but we can also use the ellipse function. The ellipse function is like the circle, but instead of definitely being perfectly round, it can be other shapes. So let's actually take a look at that. First, the circle function has its x and y position and its diameter. And looking carefully, we see that the x coordinate and y coordinate for the circle and ellipse functions will not be the top left corner, but it'll be the center. So read your parameter descriptions so that you know what to expect out of these functions. So going back here, wait, sorry, I wanted to go look at the ellipse function. So right there it is, it's right above the circle. This one has our x and y coordinate of the center, and then the width and the height instead of the diameter. And if we just specify one of them, just the width, then we're gonna get a circle. So we can do that. So I'll say ellipse. And I'll just choose some random numbers again, 100, 100, 50, 50. See how that looks? That looks pretty good. I'm gonna mess with that fill a little bit. I'm gonna try to add some more blue and see if we get a paler sun. That looks nice to me. And I think I'm gonna make it a little bit bigger. So I'll increase these two last parameters. And I'm gonna just get rid of the last one because I want it to be a perfect circle. So I'm gonna say, let's try 100. Let's see what that looks like. I think that looks pretty good. I might, yeah, I think that'll be good enough for now at least. Okay, so next up, let's draw a cactus. So I want to put like a saguaro cactus right here. So this one, I want to introduce a new concept just to help us along with drawing this. I'm going to introduce a use of the console and a system variable. So let me just go over here. A system, variable. A system variable is a variable that we don't define, but that is defined by the coding environment in which we're working. So there are multiple system variables that are available to us. If we have our canvas, there's a lot of system variables, but the ones that we're going to just introduce first is width, height, mouse X, and mouse Y. And note the capital X and capital Y here. So if we ask the program to tell us the width, it'll tell us, it knows the width of our canvas. And we can return the height of our canvas. My height is 400 as defined by this parameter right here. And my width is defined right here. So I have those system variables of width and height. Those are built into P5. And if I want to use those, let's just before I move on to using them, actually, let's just look at those. So I'm gonna remember we have the console.log, and this is going to be used to put information into this console down here, so we can debug, we can check what's going on inside of our code. So I'll say console.log width, just so we can see that number exist. So 400. So every time the draw function loops, it's printing the value of the system variable width down here into the console. Same as with height. Boing. They're the same number because it's a square, right? If I change these numbers, like if I change the height, if I change the y, the y-axis height here to 600, now it's going to be weird looking, but now you can see down here, our number has changed because this height variable is tethered to whatever the dimensions of our canvas are. So just going back, now if I had worked on designing this sketch at 400 by 400 pixels, and then I was like, I actually want it to be bigger. I actually want it to be 600 pixels. Or say I'm a designer and I had to make multiple versions of this to run on iPhone, iPad, Chromebook, big computer, whatever. I might want to have some more variability built into my system. So if I just change the canvas size in here, right, then what I've drawn no longer looks the same, right? So I want to make sure that what I've drawn is going to look the same even if I change that width and height. So what we can do then, in like this rectangle, which is drawing this desert ground, instead of having these numbers hard-coded in, I can use a little bit of math and use those height and width system variables that are defined here. I can use those to make my my code adapt to whatever size my canvas is. So, for example, this one right here, this number is 350. Let me just reset things to being 400 real quick before I. This is set to 350. That's the y coordinate of this top left corner of the rectangle. And that is 350 because it is 400 pixels down, then minus the height of this rectangle, which is 50. So this 350, we can think of it as 400, all of the width, minus whatever the height of that rectangle is. So I can replace this with height minus 50. And I could go even farther and make this 50 something dependent on the height. I don't want to go too far down the rabbit hole because there's a lot you can do. But now if I run this, it's going to look exactly the same. But if I change this to
100, okay.
Now, it's still at the bottom, and that looks better. Let me just get that back. What? Sorry, my phone, I'm getting a spam call, and I thought I turned ringing off on my... 1 second, I'm gonna stop sharing my screen and turn this off. Otherwise, I'll go insane. Oh my goodness. Okay, that's what you get for having multiple Gmail accounts tied to phone numbers. Okay. Okay, we're back. Okay, so that explains that one. And then if I change the width, right, I also might want to have that be adaptive as well. So that would be just changing the width of our rectangle to match the width of our canvas, just so it matches up. Like I said, we can go even further than this. We could have the sun change to match, and we could have the size of this ground change to match, but I think I'm just gonna let it sit right here. Oh, and I kind of like this aspect ratio. This kind of looks nice. So let's just stick with it as it is in being 600 wide and 400 tall. And we'll just stop with having this rectangle be defined by those system variables. But now this is the next step in our use of those system variables along with the console. And let me just make a comment really quick. All right, so the console can display values of variables for us to debug and design and work with our process, whatever it might be. And one second, let me make another comment here. I mentioned two other system variables, mouse X and mouse Y, and those are the location of our mouse cursor. That is the X and Y coordinate of the tip of our mouse cursor. So this could be really helpful to know when we're in the design phase of making things, because if I am writing those into the console where my mouse is, I can be like, oh, I want the cactus to be about here, and then I can see down here what the coordinates of that point are. So I'm going to, down here in my console log, I'm going to replace height with mouse X. And let's just look at that first. So now you see, if I go all the way to the right here, you see that my number in my console is 598, almost 600, and I can actually go past, not out of the browser window, but I can go outside of this. So we're just getting the x-axis mouse position now, but we want to get the mouse y position as well. So now, this is another thing we haven't covered yet, but this is, in short, it's called concatenation. And it's where we can, instead of like adding things together, we just smash them onto the end. So I'll just do it and we can look at it real quick. So mouse X plus a comma and a space plus mouse, mouse Y. Remember, capital Y and capital X. So now what it does is it takes that mouse X number value, puts a comma on the end, and then puts the Y position of my mouse. So now I can get the XY coordinate down on the console of wherever my mouse is. So yeah, concatenate is a good vocab word to keep in there. All right, so now it's just about time to make a cactus. So I'm just going to leave this down at the bottom of the window here. I'm going to keep working right here. So a saguaro cactus, let's see. I think I spelled that right. I think so. A saguaro cactus is like a pale green. So we're going to want to choose a fill that matches as such. So fill Pale green is going to be a little bit of red, a lot of green, and maybe a little blue. So let's just say, I'm going to say 100, 255, 70. Let's just try that out. And I'm just going to draw a rectangle just to see that color. So I'll say 300, 300, 50, 50. So this rectangle will be, its top left corner will be 300 pixels over, 300 pixels down, and it'll be 50 pixels wide. So it'll be right about here and right about this big. Oh, and don't forget your semicolons after your lines of code. Oh, I was a little off, but yeah, that's too vibrant. So let's bring our red up to mute that green out. And let's bring our green down actually, so it's a bit darker. We'll say 180. And I'm gonna bring that red down actually to 100. And that's a little too blue, 40. Still a little too vibrant. I'm gonna have to bring that red back down a little bit. I think I'm a little too dark now, actually. Close. There, I think that looks good for me. Okay, so let's say I'm gonna want to have a rectangle. I'm gonna do a rounded rectangle to start. Yeah, I'm gonna do a rounded rectangle to start. So I'm gonna put it right about here. So I'm gonna say I want the upper left corner to be where my mouse is. So I can look down at the console and I'm just gonna round that to 450 in the x-axis and 200 pixels from the bottom, or 200 pixels from the top of the screen will be my y-coordinate of 200. So let's change that, this rectangle to 450 for the x coordinate, 200 for the y coordinate. And then if I want this to come just a little bit below the ground, so it looks like it's like growing, right? Then I'm gonna say that I want this to be, so 360 is my y coordinate of right here, which means that that would be 360 plus 200, 560 for the height. And we'll just say 50 for the width. Oh, that's too far. Oh, I was, what did I do? 200. Oh, I added, I should have subtracted. Whoops. 160. There we go. So that's a little bit fat for a cactus, I would say. So I'm gonna make that, try that 30. That looks pretty good. And so now I wanna round those corners out. So let's go back to our reference section, go to our rectangle, our rect function, check it out. And our optional radii, we have, it goes in order, top left, top right, bottom left. So it goes clockwise. I know my image is backwards for you, but it goes clockwise, starting at the top left corner. So I'm just gonna start adding some parameters here, and I'll just make a comment, rect, using rounded corners. So the top left, I'm gonna say that I want a 5 pixel radius. Let's just see what that looks like. That's not enough. We'll try 15. Oh, I've rounded all of them, but that looks pretty good. That looks like what I want for the top corner. So 15, 15 for my top left, top right corner. And for the bottom ones, I want it a little bit rounded so it's not too aggressively like digital looking. So I'm just gonna say, I'll try 4 and 4 for the bottom ones. Let's see how that looks. Yeah, I think that looks pretty good. All right, I like that. Did I hear something? I guess I made it up. Okay. And so, yeah, this isn't going to be perfect, this next part, but I'm going to make a couple other rectangles. So I'm just going to copy those rectangles because I want to make two other arms for the saguaro cactus, right? Like your standard like roadrunner cactus. So one, I'm going to want to have it be a little bit over. So I'm going to have the x coordinate be a smaller number. So I'm going to just comment one of these out just for now. This x coordinate, I'm going to try 350. Oh my, far too far away. Let's try 400. Oh my. That looks better. Let's try, actually, I'm going to make it a little bit thinner too, because if it's an arm, it might be a little bit thinner. Let's try 25 pixels wide, and I still want it to be a little bit closer. Let's try 425. Oh, too close. 420. Yeah, that looks good. And I want to move it down a little bit because I want the central piece to be a little bit higher or taller. So I'm going to move the the y coordinate. I'm going to move it down by increasing this number. And I'll just add some comments really quick. Cactus main body, cactus left arm, and this will be the cactus right arm. Give myself some line breaks between there to make things a little bit easier to see. Yeah, that looks fine. Okay. All right, so I want to increase this y coordinate number to move that left arm down. So just try 210. Yeah, I think that maybe a little bit further down. Try 215. Good. And we'll do the other one as well. We'll bring this other one into play, and I'll actually, before I do that, I'll make this one shorter. So instead of 160 in height, let's try roughly to about here. So I'm going to guess that that's about 80. No, that's far too big. I'm going to say 60. Yeah, that looks pretty good. And so then my my cactus, my left arm is going to be pretty similar to my right arm, so I can just copy and paste that again. But now instead of being at 420 pixels from the left side of the canvas, I want it to be on the other side of the main body of the cactus. So I'm going to say that this is going to be, okay, we can actually do this mathematically really quick. I'll demonstrate that now. Let me switch my camera. Okay, so I'm just going to use the same drawing. So if we have our main body of our cactus, we have our left arm, and we're going to have our right arm, right? So we have the distance to the main body of the cactus. We know that. And now we know the distance to the left arm. This is 450. This is 420. And we know the width of our cactus bodies. This is 30. And this is 25. Right? So that means that I'll make another drawing. Okay. So if we have 25, 30, and this here is at 450, and this here is at 420, then that means that right here is 420 plus 25, 445, which then in turn means that this gap is 5 pixels wide. So then that means that we want this gap to be 5 pixels wide as well. So then we know that we have 450 plus 30 plus 5. So that means that right here should be 485. So I don't have to always guess. There's sometimes where I could just draw out what I have on screen and figure out where I want to place something. So 485, unless I've made a mistake, which is totally possible, is where I want that. So let's just take a look. Hey, not bad. And I want this one to be a little bit lower, so it's a little more expressive. And maybe I could even give this thing some eyes if I felt so inclined. I'll make this at 220, but then I'm gonna want it to be a little bit shorter so that the bottoms match up. No, I wanna have them be the same. I'm gonna give it a little bit more, 225. All right, I think that's looking pretty good. This is taking longer than I had hoped for. I wanted to give you all some more time to work in class, but okay, I'll just close these up, just really kind of messy, and then we'll use the rest of the time for questions and work time. All right, so we're gonna just quickly, we're gonna join those up. So we want a rectangle that is right about here and a rectangle that's here. Excuse me. So we're going to do we'll just copy this one. Remember, copying and pasting is also going to save you so much time. Remember to copy and paste things so you know how to just type things out. So the X position of this rectangle is going to be the same. Right? We want it to line up right with this. The Y position is going to be different. This is going to be whatever the Y position of this plus the height. So this is going to be 215 plus 60, 275. Actually, well, let's just see how it goes. And the width, we don't want to be 25. We want the height to be 25, so it matches the thickness of that arm. I'm going to change that to 25. And the width we can actually figure out from that drawing we just made. So we're going to change this parameter, the width of that rectangle, taking into account what we just drew. So we want it to go from here to here at least. So that would be 25 plus 5 is 30. So we'll just make it, we'll make it 35 just to make sure it gets there. So that looks good, except for now we have this weird corner rounding situation to deal with. So that means we want to modify these last 4 parameters. So, okay, let's see here. And I'm gonna unround this, the corner of this arm on the left. Yeah, so now if you can see there, that is a sharp corner. And so that means when I put another rectangle that has a sharp corner, it's should match right up. So that means I want to change this one because that, oh, sorry, I don't have my face here. I want to change the first corner rounding parameter because that's the top left. I'm going to change that to a 0. Oops. That's looking good. And I want the top right on that one also to be a 0. That's looking pretty good. Oh, and I want to change the bottom right of this one to be a 0. So this one, this 4 should also be a 0. So on this rectangle for the bottom part of the arm, we're going to want to round out the bottom left corner, which is right here. So I'm going to say that I want this one to be, let's try 15. Oops, sorry, that I chose the wrong one. I want this last one. Yeah, that looks pretty good. Maybe a little bit more even. And I'm actually going to set this bottom right corner to 0 just in case we get any weirdness here. So let's try 25. I think that looks acceptable. So now I'm going to do something similar for the right arm. So first thing, I'm going to copy what I did over there or follow suit. I'm going to unround those bottom 2 corners. Remember, The last 4 parameters here are the radii of all of the corners going clockwise, top left, top right, bottom left. So changing those last 2 to 0 will round out these corners. As you can see, now it has those rounded out. Excuse me. And so now I need to figure out the position of this arm, where that one's going to come in. So we can go back to our drawing. And so this, we want to know where this position is. So that's 450 plus 30 plus the width of that. So 480 is the exact end right here. And I'm going to go once again, just 10 pixels in. So 470 will be the location of the beginning of this rectangle. So we'll just type it in, rect 470. And we want it to go, look back at our drawing. So we have our 5 pixel gaps between. This is 30, this is 25. This is 480, as we established with our previous math. So that means, and if we start our rectangle 10 in, then our X position is 470. Our width is going to be 25 plus 5 plus 10, so 40. Our our Y position is going to be equal to the bottom of this one, which is, if we look at that, if we look back at here, this right arm, it starts at 225 right here, and it's 60 long, so 285. And the height, we're gonna have it equal to the width of this one. All right, so let's just pop those in. So 470, 285, 40, 25. And we haven't rounded any corners yet, but let's just see how that looks. Hey, not too bad. And so the only corner we want to round is this bottom right one. So that means, remember, we have our top left, top right. Those are going to be 0 radius, 0, 0. And nice to keep things looking good, nice and clean. All right. And what did I say for the other one? 25. And then 0. And I could go further and add like a vulture circling and a cow skull or whatever, make it look like an old Western. But I think we'll stop there. All right.